So here is another question from ITJ PYQ. The question is from the chapter friction. So here is the question. An insect crawls up a hemispherical surface very slowly as shown in the figure. The coefficient of friction between the insect and the surface is 1 by 3. That means mu is given here. Mu is given here, that is equal to 1 by 3. So if the line joining the center of this hemispherical surface to the insect makes an angle alpha with the vertical, then what is the maximum possible value of this alpha is given by, we have to calculate. So here I will draw this diagram again. This is our hemispherical bowl, and this is the vertical line, let us suppose, and at this position insect is there. Okay, so this is our insect here. This angle is alpha. So what are the forces acting on this insect is, one will be the downward force. Let us suppose m is the mass of this insect. Okay, so mg will be the downward force, that is the gravitational pull of this earth, and one force will be the normal force due to this surface, contact surface. Okay, let us suppose this is n. So if I extend this line like this, then this angle will also be equal to alpha. So the component of this mg along this line, that will be equal to mg cos alpha. Similarly, the component of this mg will along this direction will be mg sin alpha. Okay, mg sin alpha. Since this insect is having a tendency to slide down, then there will be some friction force acting in this backward direction to support, to make it not to slide. Okay, so now we have to apply the equilibrium conditions for this insect. So if I apply the equilibrium condition perpendicular to this surface, then normal force will be equal to mg cos alpha here. Okay, and the value of this frictional force we already know, that is equal to, if this block or this insect is stationary, then static friction will be there, that is equal to mu into normal. So here value of mu is given, that is equal to 1 by 3, and normal we have calculated, that is equal to mg cos alpha. Okay, so along the line parallel to this surface, if I write the equation of motion, since this insect is not moving, then the equation of motion I will write here. The net forces will be equal to 0. That means this frictional force will be balanced by this static friction will be balanced by this mg sin alpha. Mg sin alpha. What is the value of this frictional force is 1 by 3 mg cos alpha. Okay, that is equal to mg sin alpha. Mg sin alpha. So here mg will be cancelled out on the both sides. Then here tangent theta is equal to 1 by 3. Okay, so what is the answer we have to check here? We have to, the maximum possible value of alpha for this insect is at rest. Okay, so here tangent theta is equal to 1 by 3, that means cot alpha is equal to 3. So tangent theta I can write 1 by cot theta, that is equal to 1 by 3. So cot alpha will be equal to 3. Okay, so option A is the correct answer.